As we consider 3xy as a solution of the system, x is greater than 0, what's the value of xy? I will show the algebraic way, and then we'll see how much faster Desmos is going to be. So this is a classic substitution problem. You could substitute in the x squared from the first equation to the second equation, and then you might as well distribute that -4 while you're there. Anytime you have both x squared and x terms, you have to get everything to one side so you can factor and solve. So we add that 4x over, we subtract the 20. You always want to make the number in front of the x squared be a 2 if possible, so we can divide everything by 2 here. It's going to make things nicer. And then we factor. We need two numbers that multiply to -8 and add to 2. If they're going to add to 2, they need to be 2 away from each other. So 4 and 2, we make the 4 positive, the 2 negative. That checks out. We then set each factor equal to 0. And we get that x is -4 and x is 2. They restrict it to x being greater than 0, so we use the one where x is 2. You can then plug that back into either equation to get the y value. I'd plug it in the first one because that one's simpler. So y is x squared or 2 squared, so y is 4. And then the last step, they want the value of xy. So for some reason they want us to multiply these together. So xy is going to be 2 times 4 or 8. Our alternative, we do have Desmos the entire time on the test. You can graph these two equations. And when you graph them, you can click on the points. You can export the point and even label it if you want. So we get our two intersection points. We restrict x to being positive, so we want that 0.24 out there. So then you just do 2 times 4 is 8. So Desmos is super powerful for some of these systems. It is worth knowing how to do this algebraically because they may change the problem in a way where Desmos becomes more difficult. But clearly for this one, Desmos is way easier. So anytime you're doing SAT math homework, always have Desmos open, and this is just desmos.com /calculator.